Okay, welcome back. Lesson 23, operations involving decimals. So we're going to look at add, subtract, multiply, and divide decimals. Most people tell me that they remember how to add and subtract decimals by hand, but multiplication and division, they get fussy. And you know, we live in this world of technology, and even in the elementary schools I see we tend to throw calculators at third graders, and I don't know if that's a good thing. We want to be able to do all of these things by hand for starters. So, step one. If you're adding and subtracting decimals, you just write the decimals so that the decimal points line up vertically, and then you go ahead and add and subtract as you normally would, and place the decimal point in the sum so that it lines up vertically with where you had it in the original problem. So there's your recipe. Let's go ahead and take a look. So if I had 85 minus 13.26, I would write 85 as 85.00. So recall that zeros may be inserted to the right of the whole number, so to the right of the decimal point after the last digit, without changing the value of the problem. So I always call these zeros trailing zeros here. They're not going to affect the value of the problem, but they line up our subtraction very nicely. So then you would subtract as usual. So I don't know if you're like me. I'm going to do this in real time. I have the answer written there, but if you're like me and you were trained to borrow, nowadays they call it regrouping, I think. But what I mean by that is 0, you cannot take away 6. 0, you cannot take away 2. So you're going to have to borrow from way over here. So the 5 becomes a 4, right? 4 minus 3 is then 1. Keep the decimal point lined up. And you had borrowed, which, you know, would make that a 10, but then you're going to give 1 to him, so that's going to make that a 9, and then he's going to become a 10. So 10 minus 6 makes 4. So what I mean is, however you were trained to borrow is what you perform. Like I said, that becomes a 9. So 9 minus 2 makes 7. And then, of course, 8 minus 1 makes 7. So you're ending up with 71.74, which is what we have here. So it may have been a while since you borrowed or done that by hand. But I do want to make a little note about estimating within your problem to make sure that your answer is in the right ballpark. So if I'm claiming that the answer is 71.74, think of money. Just think of money when you think of decimals. So just think that's really, really close to $85, right? I'm just pretending here. So we're all comfortable with money. And 1326, well, gee, that's really close to $13, right? So just as a ballpark estimate, 85 minus 13 would be $72, right? And so this is in the ballpark of $72. So we're happy with that, right? 71.74 is very close to $72. Let's try again. So this one I started, but I wanted to do the lineup with you. So 23.8 plus 32.1. If I'm going to do it by hand, I'll place the 32.1 right here. I'm still getting used to my magic pen that I'm using here, so forgive the handwriting. Line up the decimal, and so 8 plus 1 is 9. Keep the decimal in position, you know. 3 plus 2 is 5, and 2 plus 3 is 5. So 55.9. And then always this question of, am I in the right ballpark? Okay, and you do that by estimating. So again, I would just think of money. You know, 23.8, well, gee, that's awfully close to $24. So if we round to the nearest whole number, it's kind of like rounding to the nearest dollar, like when you do it at the grocery store. And 32.1, well, that's really close to $32. And so I'm just kind of writing over here, let's estimate. So that will lead us to $56 as our estimate. And gee, that is awfully close to $56. So it gives us a feel that our answer's on track. Okay. Let's see if we have any more. Yep, let's try the next slide. Let's try subtraction without a calculator. So remember that business with lining things up. So 117.345, and then it says minus 32.07. So I have to line up that decimal, 0.07. And then if you like, you can put that trailing 0 there as a placeholder. Okay. And then just perform subtraction as usual from there. So 5 minus 0 is 5. 4, I cannot take away 7, so I borrow from the 3, so that becomes a 2. And I'm borrowing 10, so, 4 becomes 14 because I'm borrowing 10, because we live in a base 10 system, right? So 14 minus 7 then is 7. 2 minus 0 is 2. 7 minus 2 is 5. And once again, I'm stuck with borrowing. 1, I cannot take away 3, so I'll borrow from this guy. And if I'm borrowing 10, then 10 plus 1 makes 11. So 11 minus 3 is 8. And voila, 85.275. And again, I have the answer here, but we wanted to try it without a calculator. And again, with the estimation, let's try that. That's kind of fun. If you think about money, well, gee, that's really close to 117 bucks. And gee, that's really close to 32 bucks. So just a ballpark estimate. So I'm just going to write here EST for estimate. That'll lead me to 5. So that'll lead me to 85 as an estimate. And what we're getting is awfully close to 85. So good. All right, let's see if I have another one. Yep, let's try the next slide. Now we get ready for multiplying decimals. So with multiplying decimals, you don't line up the decimals. You multiply the decimals as though they were whole numbers. So the easiest way I can say is pretend the decimals weren't even there, totally ignore them. Then you count out how many total digits behind the decimal at the end of the problem. So the decimal point in your final answer in your product is placed so that the number of decimal places in the product is equal to the sum of the number of decimal places in the entire problem. Now I know that probably doesn't make a lot of sense at first, but let's dive in. So 32.3 and 1.9. Now it may look as though I'm lining up the decimals here, but that's just because they inherently line up. So what I'm getting at though is when I multiply this, I completely ignore the decimals. And in fact, let me scoot this next problem down a little bit. I'm going to scoot this one way down. Okay. So I'm going to completely ignore these decimals and then I'll just count them up at the end. So 3 times 9 is 27. Carry the 2. 9 times 2 is 18, 19, 20. So notice I'm just kind of ignoring the decimals. And 9 times 3 is 27 plus 2 is 29. Still ignoring the decimals. Put my 0. Then remember with multiplication, you go this away. So 1 times 3 is 3. 1 times 2 is 2. 1 times 3 is 3. And now, still ignoring the decimal until the very end. So this makes 7, this makes 3, this makes, carry the 1. All right, so here I arrive at 6137, but clearly the answer is not 6,137. Where does the decimal go? So I'll do this in another color. Aha, there was 1 digit behind the decimal in this factor and 1 digit behind the decimal in this factor. So 2 total behind the decimal. I'm writing in cursive here. So that means that there has to be 2 total digits behind the decimal in the final answer. Aha, so 61.37. So just note to self, 2 total, yeah, 2 total digits behind the decimal. And I mean, if you think about it, you can still do estimation. I mean, think about 32, that's really close to $32, right? And 1.9 is really close to 2. So even if you just think about rounding to the nearest whole number, and if you just took 30, so 32 times 2, you would get 64. And 64, we're getting 61 and some change. It's in the ballpark of 64, though. You know, it's not. At least we're not trying to say the answer is 6,137, right? So it has to be in the ballpark of 64. So again, that's just my estimate. Okay, hope that helps. Let's try the next one. So 2.54. And notice I am not going to line up the decimal. 1.2, I'm just putting the number right underneath it, not lining up the decimal. And then just multiply as usual and ignore the decimals until the end. So 4 times 2 is 8. 2 times 5 is 10. Carry the 1. 2 times 2 is 4 plus 1, that's 5. And I put a 0, and then I move into this digit. So 1 times 4 is 4. 1 times 5 is 5. 1 times 2 is 2. And again, just totally ignoring the decimals till the moment is right. Now the moment is right. So now let's count. I'll do this in another color. Let's count the total digits behind the decimal. So 1, 2, 3. 3 total behind the decimal. So guess what? 1, 2, 3, boom. So 3.048. So I know this is not a calculator course, but you know, when it's midnight and you want to check your answer, feel free to check it on a calculator, but only after you've convinced yourself that you know how to do it by hand. So you see what I did. I did it by hand, and now I'm running it on the calculator just to check. Okay? So the calculator is just a crutch, and we don't want to get you too dependent on that. Okay? Let's see what's next. Shortcuts for multiplying by powers of 10. These are just handy, I would say. So if I'm multiplying by 10, 100, or even 100,000, what I can do is I can count the number of zeros. So there's 1 0, 2 zeros, there's 5 zeros. I can count the number of zeros and slide the decimal point to the right, that many. So if I want 76.543 times by 10, notice the answer is 765. So it looks like I just slide the decimal to the right one, and voila, I have 765.43. And if I want to multiply this by 100, I can slide the decimal 2 and arrive at 7654.3. So this is like allows you, if you're multiplying by 100, you can slide the decimal 2 to the right. If you're multiplying by 100,000, you can slide the decimal 5 units to the right. If you're multiplying by 1,000,000, you can slide the decimal 6 units to the right, etc., etc. So let's play some mental math here. 1, 2, 3, 4. I see 4 zeros. Note to self, I'm going to slide the decimal 4 units to the right. So note to self, 4 units or digits to the right. So I'll do that in real time. So if I have 34.567, what I always do is count the slots. 1, 2, 3, 4. So if I take this decimal and slide it 4 to the right, I'm going to end up back here. You can fill that in with a 0. So you'll have 3, 4, 5, 3, 4, 5, that's terrible, 5, 6, 7, 0. So that's really, 345,670. So again, you can always check. So even though that's a little shortcut gimmick, you can check. So 34.567 times 10,000. And you've got 345,670, which is exactly what we got. Okay, so again, you're just noticing that, gee, there were 4 zeros, and I'm going to slide the decimal 4 to the right. Okay, let's see what other goodies I have there. Careful if your power of 10 is a number less, just notice that was a typo there, less than 1. Move the decimal point not to the right, to the left, the same number of places as there are decimal places in the power of 10. So what I'm getting at here is if clearly 0.01 is less than 1, right? So if I'm taking 8.57 times 0.01, I'm going to slide the decimal 2 to the left. So if I slide the decimal 2 to the left, I'm going to have 0.0857. Okay? So since there are 2 decimal places in 0.01, I will move the decimal 2 places to the left. Let's see if I have another practice. You know what? I'll just cook one up now. So what if I have 3.045 and I want to multiply that with 0.001? Okay, so I'll do this in another color. So I have 1, 2, 3. So I have 3 decimal digits behind the decimal. So I'm going to slide the decimal to the left 3. So 1, 2, 3. I would have to slide that decimal to the left 3, and then where would I end up? So I'd end up at 0.00305. And again, those are just handy little ways to multiply by powers of 10. Because, I mean, bear in mind, when we speak of powers of 10, bear in mind that like 10 cubed means 1,000. And 10 squared means 100. And this is something to think about. And 10 to the first power is obviously 10. So what's 10 to the negative first power? 1/10, which is 0.1. And what's 10 to the negative 2 power? 1/100th, which is 0.01. So that's why we speak of powers of 10, multiplying and dividing by powers of 10. That really means multiplying and dividing by these such numbers. Okay? Hope that helps. Now we can start to answer lots of things, perimeter and area of a circle problems. Now that we know how to multiply, we can use geometric formulas very easily. So here's an example. If I order a 6-inch pizza, and let's say that means the radius is 6 inches. What's the area of my pizza and what's the circumference of my pizza? So, and I gave you hints for formulas right here. If it's been a while, circumference is pi times diameter and area is pi r squared. So let's go ahead and target the area. And I always tell people, draw a picture. Always, always, always draw a picture. I can give you partial credit if you draw a picture. So 6-inch radius, that means from the center on out till we touch the circle, that's 6. Okay. Now, area is said to be pi times your radius, which is 6, squared. Well, 6 squared is 36, and pi we're going to use 3.14. So you really end up taking pi times 36. Well, if I'm in a no calculator course, then I have to take 3.14 times 36. And in fact, I'll use that parenthesis notation there instead. Let's just make that a big parenthesis. Okay, so I'm going to hit pause as we do that off on the side. So again, what I want you to do is take 3.14 times 36 and just by hand kind of do that off on the side. I'll hit pause. Okay, hopefully you tried it off on the side on your own. Did you get 113.04? So now the question is the units. So area then is 113.04. Area is always square units. So here we're dealing with square inches. You can literally write square inches, or you can write inches squared. Okay, so we tackled area. Now let's tackle circumference. Now remember, I'm going to redraw this. Remember, circumference is the distance. It's a terrible circle, I know. I probably should have used the circle drawer on here. See if I can find it. Aha. Oh, well, that's a lot prettier, huh? So there, now I use the circle drawer. Now remember that we have a 6-inch pizza, talking about its radius. Okay, so if that's 6 inches, my question is then what's the diameter? So, oh, okay, well then the whole way across, from here, the whole way across is your diameter. Note to self. Just kind of squeezing that in there. So diameter, long story short, is twice your radius, which is 12. All right, so since the diameter is 12, I need that because my circumference formula says to take pi times my diameter. So I have to take 3.14 times my diameter, which is 12. Okay, so for circumference, that means we have to crunch this out. And like I said, I'll hit pause and let's go off on the side in the margin somewhere and figure that out. Now remember the trick. You ignore the decimals and put them in at the end. So like 4 times 2 is 8. 2 times 1 is 2, 2 times 3 is 6. See, I'm ignoring the decimal until the end of the problem. And then 0, 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3. I don't have to hit pause, we can do that. 6, 7, 3, and then count the decimals up at the end. Boom, boom, there's only 2 behind the decimal. So 2 behind the decimal in the end. Now circumference, I wanted to reiterate that. Circumference is like it's like the crust, right? So it's going around the circle. I'll do that in another color. So circumference is if I'm traveling around the outer edge of the circle. It's the distance around that outer rim of the circle. That's your circumference. So when you think of circumference, think of the length. If you were to put a piece of string around the edge of your circle and measure the length of that. So 37.68. Now again, it's so tempting to, crunch it on a calculator, I know, but do that at the end. So 3.14 times 12, just to double check your answer. So 37.68, 37.68. And again, the units on circumference are just plain units. So that's just plain inches. Okay. All right. Hope that helps. I know that was a lot. That was a big lesson. I have a really brief recipe for division of decimals, and I will just I'm going to let you read through this on your own, but the big gist is that if your divisor is not a whole number, you need to move the decimal point to the right until your divisor is a whole number. So I'll let you read through those examples on your own, and let's do these together real quick. So here the divisor is clearly not a whole number, so I'm going to slide 1 to the right, slide 1 to the right. Okay, and then I do a rewrite. So I'm like, okay, now I've got 12 going into 360.48. So I like to slide it, rewrite. So 12 into 36 goes 3, and then perform your, and by the way, line up your decimal now where it goes. Okay, subtract. 12 doesn't go into 0, or goes into 0 0 times. And then we could just continue the division. And bring down 1 at a time. So 12 does not go into 4. And then remember, you only bring down 1 at a time. But 12 does go into 48 4 times. So voila, 30.04. Now what I like to do, is after I've done it by hand, again, I'm going to type the original in. So the original was 36.048 divided by 1.2. I like to type that in. See, I've got 30.04. And voila, 30.04 was our final answer. Okay? And last couple here. The divisor is a whole number. So note to self, divisor, let's just make sure we have the language under control. That's our divisor. This here is our dividend. And the final answer to the problem is called a quotient. But okay, now the divisor is a whole number, so we just take the decimal and line it up above where it is. 14 does not go into 0. 14 does not go into 0. 14 does not go into 5. Aha, does 14 go into 56? Maybe, right? You say, maybe about 4 times. And you can always go off in the margin somewhere. You can say, okay, 14 times 4, 6, carry the 1. Aha. Yeah, it happens to go in evenly. So it's 56. Draw the line and subtract. And then bring down the next guy. 1 at a time. Does 14 go into 2? No. Draw the line and subtract. Bring down the next guy. Does 14 go into 28? Yes, it does. 2 times. So 0.000402, and you can certainly check that on your calculator. And then, this is a fun one. Divisor is still a whole number. So if the divisor is a whole number, I'll just line up the decimal above. So I'll just draw a little arrow here above where it is. Does 3 go into 2? No, it doesn't. Does 3 go into 20? About 6 times, right? Come back around and multiply. 6 times 3 is 18. Draw the line and subtract. That's a 2. Now you say, now what am I going to do? Well, you can add as many trailing zeros. These are called trailing zeros. Add a bunch of trailing zeros until you figure out what the answer is. That's what I always say. So let's bring down this trailing zero, meaning either your decimal is going to terminate or repeat. So let's figure out if this decimal, is it going to terminate or repeat? It's got to do one of the two. So does 3 go into 20? Nope. Not evenly. It goes about 6 times. 6 times 3 is 18. Draw the line and subtract. bring down another trailing 0. Hey, gee, I end up with 3 going into 20, right? And so you quickly start to realize it's 0.66666. So it's a repeating decimal, and we can express that as 0.6 repeater. So the repeating decimal, we can put the bar over that which repeats. Okay, let's try again. Now, when you speak of division this way, this is your dividend, this is your divisor. So I really have 2.8 going into, so you can rewrite the problem, 258.3. And I think, by the way, let me check. Yeah, I think this is our last by hand problem. The last page is simply just a reminder. So this is our last sweat equity here. Let's do it together. Divisor's a decimal, so slide 1 to the right, slide 1 to the right, place the decimal above. And sometime with me, sometime I like to just totally rewrite it. So I like to say, okay, 28 into 2583 point, and then I like to rewrite the problem so it's not a nuisance. 28 doesn't go into 25, but 28 goes into 258, and there's where you're kind of guesstimating. You're saying, maybe about 9 times. And you can go off on the side. I always say go off on the margin somewhere and figure out what that'll be. 8 times 9 is 72. Carry the 7. 9, 18. So that's what, 252? So it's really close, right? So 252, draw the line and subtract. 8 minus 2 is 6. Bring down the next guy. Does 28 go into 63 evenly? No, but it goes in about 2 times. 2 times 8 is 16. Carry the 1. It's going to be 5. And you can bring down, like I said, you can add as many trailing zeros as you need, after you perform that subtraction. So let's borrow here. That'll become a 13, so that's a 7. And I'll bring down one of those trailing zeros, and then 28 into 70, say maybe about twice. And that's still going to be, 56. Draw the line and subtract. And that's going to be a 1, a 4, and I'll bring down that very last 0. And then I say, okay, 28 into 40. Well, maybe it goes about 5 times, but I'm going to go off on the side and see. So some of that is just kind of a number sense, and you can kind of go off on the margin somewhere and work it out. 10. Aha, gee, it happens to go in evenly. So it goes in 5 times. And we end up with a terminating decimal. That's what I mean by a terminating decimal. So 92.25, well, I had the answer here. And now we see how that works. Now, if you're a person trained in Europe or Vietnam or China, your division algorithm may look different than our division algorithm, but we should be arriving at the same spot, long story short. So I did want to just reiterate here that this number, the 258.3, that's your dividend. And the 2.8 is your divisor. Okay, hope that helps, and I'll let you read through the final blurb there on the shortcut for dividing by powers of 10. So if you're dividing by 10, you slide the decimal to the left 1. If you're dividing by 1,000, you slide the decimal to the left 3. Those are just shortcuts. So here I've got 1, 2, 3, 4, so I better slide I'm dividing by 10,000, so I better slide my decimal to the left 4. So 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to end up with 0.0003334. Okay? All right. Hope that helps. I know that was a ginormous lesson on operations. Hope that helps. Good luck out there.